So just for kicks, we're going to talk briefly, very briefly hopefully, about some other Java streams factory methods. These are not nearly as common, but they're worth knowing about. And there are other ways of being able to create streams from various types of entities. So one way to create streams is from the IOStreams classes. And we've seen a couple examples of this earlier. And in this particular case, we can use the BufferedReader.lines method to obtain the lines of a file. So here's an example that you can try out if you're so inclined, where we're going to have a method called print file lines. We give it a file name, and this thing is going to go ahead and use a buffered reader. So we say files.new_bufferedReader, and we give it the name of the file that we want to read from. And that will then go ahead and create a buffered reader. And then we're going to go ahead, as we'll see, and use the streams features to actually do something with it. By the way, the reason we're doing it with this somewhat idiosyncratic syntax is to use something called a try with resources block. So this funky thing that we're showing here is what's called try with resources. You may be familiar with try in the context of Java exception handling, like try catch. You can see try and catch. Try with resources was a feature, I think it was added maybe in Java 7 perhaps. And what it does is it ensures that the object that's created inside the parens will be automatically closed when the try block exits, no matter how it exits. If it exits for an exception or normally, that object will be closed. And we want that to happen because we don't want to leak the resources. So the question here is try with resources somewhat like the finally block? Sort of, in the sense that finally always gets run no matter what, even if an exception is thrown. The difference here is what's always getting run is closing the object that was created in the try portion of try with resources. So that's the part that's similar to finally, in that something always happens irrespective of whether an exception is run or not. Finally, as you probably know, can have sort of arbitrary code you put to clean things up. So it's try with resources is not in lieu of finally. You can have finally there for other reasons, but try with resources will always make sure that that object inside the parens will get closed and the resources will be freed up. So yeah, that's a good observation. So what we're going to do here is once we've gone ahead and created this reader, then inside the try, the body of the try block, we go ahead and say, hey, reader, get me all the contents of that file as a stream. So the .lines method converts the buffered reader into a stream, and then for each element in the stream, we're going to go ahead and print the results out. So that's actually a pretty common and useful thing to do. There's another way to do this, which is very similar, and this is to use the Files.lines method. So in this particular case, we can use Files.lines, which is another part of the Java IOStreams package, in order to be able to get ourselves a stream, and then for each element in the stream, we're going to print out the results. So very much the same thing, just using a different way of using Java IOStreams. Once again, notice we have the try with resources block here to ensure that the stream variable and all contents associated with it will be cleaned up automatically when the try block goes out of scope. So here we have another example where we have a stream of random numbers that can be obtained from Random.ints. There's also a Random.longs that works the same way. And what this does is this will generate a stream of random integers, and this stream is unbounded. It'll go on forever if we don't limit it somehow. And this is going to be generating random numbers between 0 and 100. You can put, of course, whatever you want. You can put, negative integer, or you can have integer min value up to integer max value, and you get gigantic range of random numbers within whatever range you give it. So you get a stream of those things. In this case, we're going to limit ourselves to the first 50 random numbers between 0 and 100, and then we can go ahead and print those results out. I tend to use ints or longs, which are two factory methods on random that create these random streams, a lot for testing, when I want to generate test data. There are not a lot of other uses I use it for, but I use it a lot when I'm generating test data. Another very interesting method that we'll actually see a bit later is stream_support.stream. And what this does is this takes as a parameter something that's called a split iterator, and we'll talk a lot more about split iterators here in the not too distant future. And it will use the split iterator to create either a parallel or a sequential stream. And you can decide whether it's going to create a parallel stream or a sequential stream when you call stream support.stream by the parameter that's passed in here. So we'll see some examples of that. And in fact, it turns out, this is a bit of a precursor of things to come, that the .stream and the .parallel stream factor methods that exist on things like collections, they all emanate from the collection interface, which is a very high up interface in the collection framework. And .stream and .parallel stream under the hood use stream support.stream to make either a sequential or a parallel stream. So you get a chance to see how that stuff works in a little bit. There's other methods that were added later in Java 8 and beyond, that create streams. Here's a really fun one. This is the regular expression mechanism, where you take a regular expression called the splitter, and then you can take whatever you want. Like in this case, it's going to be a bunch of, it's going to be a big file with a bunch of contents. And you can then split these contents using the regular expression and get a stream as a result of that. So in this particular case, we're going to go ahead and get all the bytes in a file and then split it according to whatever regular expression is passed in there. And we end up with a stream of strings that are split by the regular expression. And yet another example, which is kind of also useful primarily for things like testing, is the generate method. And this is an interesting method. What this does is it will generate an infinite number of whatever objects you indicate via the constructor reference that's passed in here. So in this particular case, we have some tree map. Tree map is a class that comes with Java. And we're going to end up wanting to be able to have a tree map, an infinite number of tree map objects that have longs mapped to strings. That's what's going to be generated. And we're going to limit it to the first 100 of these things. And so we're going to end up with 100 tree maps. Now, why would you want 100 tree maps? Well, that's a very good question. And again, I use this stuff frequently for various kinds of testing purposes. But that's another example of generating streams. So that's the end of the overview of other streams, factor methods. There are, believe it or not, even more of them, but we're going to get lost in the weeds if we continue down this rabbit hole for too long. So these are just some things to be aware of. So the key thing to note here is that we can create streams from various sources, and then later we'll talk about how the streams are actually created. And streams are actually created typically under the hood by a combination of this stream support.stream utility factor method and the concept of a splitterator. And a splitterator is used in that first phase of a stream where we want to take some input source and split it up into chunks that can then be processed by later phases in the apply and combine portions of a stream.